Hello, everyone. Welcome to Calculus Lecture 14. And today we're going to be talking about the mean value theorem and Rolle's theorem. Okay, so let's start with Rolle's theorem. Mean value theorem is the generalization of Rolle's theorem. All right, so say we have some differentiable function f on some interval ab. And suppose, moreover, that f of a equals f of b. And then there is some x between a and b. Where the derivative of f is 0 at x. So that f prime of x equals 0. So basically, here's a picture. We're going to have our graph. It's differentiable, and then we have 2 points, say here and here, where the value of the function is the same. Then there's some point between those 2 points where the derivative is 0, meaning the tangent line is horizontal. It makes sense because assuming the function is not constant, if it is constant, the derivative is 0 everywhere. But if it's not constant, then it's going to be either increasing or decreasing here. And then it has to start going the other way to come back to the same point. And when it does that, there's going to be a local minimum or maximum. And at that point, the derivative will be 0. Now, we also have the mean value theorem, which is just a slight generalization of this. So let's write this one down as well. So now we have some function, again, f that's differentiable in some interval ab. But now f of b and f of a do not have to be the same. But even then, there's going to be some point between a and b I'm going to call this point x, so that the derivative f prime of x is equal to f of b minus f of a over b minus a. So what's this telling us? We have our function. And we choose any 2 points. They don't have to be the same. So we can have this point and this point. Now, what is this value? F of b minus f of a over b minus a. That's the slope of the line connecting these 2 points. And we're saying that there's a point in the middle, so that the slope of the tangent line, the derivative, equals this slope. So basically, we have a line, a tangent line to some point here, parallel to the line connecting these 2 points. And that also sort of makes sense. If you start going away from it, then you have to come back. And there's some like sort of turning point where the tangent line would be exactly parallel. So basically these guarantee certain values exist. So let's do some practice problems based on these. And then we'll also talk about the intermediate value theorem. So here's an example. Let f of x equal x squared plus 1. On the interval from 1 to 3. Let me just write this as, all right. So find the value guaranteed by the mean value theorem. On 1 to 3. So there might be more than one value. If there is, you just have to find one. So I'll pause for a minute so you can try to solve it, and then I'll give the answer. All right, so let's talk about it. So what is the value guaranteed by the mean value theorem? So 1 is our A and 3 is our B. So so A equals 1, B equals 3. F of A is f of 1, so that's 1 squared plus 1, which is 2. And then f of B is f of 3, which is 3 squared plus 1, so 9 plus 1, which is 10. And the mean value theorem tells us that there exists, this is a symbol for there exists if you haven't seen it before. It's just shorthand notation, so I might use that sometimes. So there exists some x between, so in the interval from 1 to 3, so that the derivative is equal to f of b minus f of a, so 10 minus 2 over 3 minus 1, so b minus a. So that's 8 over 2, which is 4. So there's a point where the derivative is 4, and we need to find this point. So how are we going to do this? Well, we're just going to take the derivative. So f prime of x equals 2x. And we want this to equal 4. We want to find x so that it's equal to 4. So we just set that equal to 4 and divide. So we get x equals 2. And x equals 2 is in this interval from 1 to 3. That is the value we're looking for. And so this is going to be the value guaranteed by the mean value theorem. Let's do another example. All right. So let f of x equal 2x cubed minus x. On the interval from -2 to 1. Right, find the value guaranteed by the mean value theorem on this interval. Again, I'll just pause for a few moments and then get the answer. All right, so let's see. So in this case, our A in the mean value theorem is -2 and B is 1. And then we need f of A and f of B. So what's f of A? So we're going to plug -2 into this. So that's 2 times -2 cubed minus -2. It seems like that's 2 times -8, so -16, plus 2 is -14. All right, so f of A is -14, and then f of B, we're just going to plug 1 into here, so that's 2 minus 1, which is 1. And so the mean value theorem tells us there's a value x in the interval from -2 to 1, so that f prime of x equals f of B minus f of A over B minus A. So that's 15 over 3, which is 5. All right, so we want to find a value of x in this interval so that the derivative is 5. So let's find the derivative now. So f of x is 2x to the 1th x. So we take the derivative, f prime of x equals 6x squared minus 1 equals 5, and we're solving this. So let's just move the 1 over. 6x squared equals 6, and x squared equals 1. So what's x going to be? It can be plus or minus 1. But remember, we're looking for a value in this interval. Well, actually, in this case, they're both there, so either one would work. I would just go with -1 since it's like in the middle of the interval. Sometimes only one value would actually be in this interval, and then we would have to pick that one. So in any case, this is our solution. X equals plus or minus 1 is going to be a value guaranteed by the mean value theorem. All right, let's do one more, maybe slightly trickier one. So now I'm going to let g of x equal the square root of 2x minus 4. And this is on the interval from 2 to 10. So again, we're going to find the value that satisfies the mean value theorem. All right, once again, I'll just pause for a moment so you can try and solve it, and I'll go over the answer. All right, so let's go over this. So we first need to find what value we're looking for. So the mean value theorem tells us that there exists some x in this interval from 2 to 10. So that g prime of x equals g of 10 minus g of 2 over 10 minus 2. So we need to figure out what this value is. So what's g of 10? So 2 times 10 is 20, minus 4 is 16. The square root of that is 4. So g of 10 is 4. And then what's g of 2? So 2 times 2 is 4, minus 4 is 0. So that's just 0. So this is equal to 4 minus 0 over 10 minus 2, which is 1/2. So we're going to look for a value where the derivative is 1/2. Now we need to find g prime of x. All right, so that's the derivative of this. We're going to use the chain rule. So we can write this out as a u substitution. So let's have u equal to 2x minus 4. And y then is equal to, so y is g of x. And that's going to be equal to the square root of u. So g prime of x is dy dx, which is dy du times du dx. So what is dy du? We're going to look at this. So y is the square root of u, which is u to the 1/2, which means that dy du is 1/2 u to the negative 1/2, right? Which is 1/2 over the square root of u. So this is going to be 1 over 2 times the square root of u times du dx, which we're just going to plug in here. So that's going to be just 2. So the final answer is 1 over the square root of u. And we can substitute for u. So that's 1 over the square root of 2x minus 4. And so that's our derivative, 1 over the square root of 2x minus 4. And we want this to equal 1/2. So the square root of 2x minus 4, that should equal 2. So we square both sides, 2x minus 4 equals 4. And then 2x equals 8, so x equals 4. And this is inside the interval from 2 to 10, so that's good. And so x equals 4 is the value we want. All right, so now let's take a break for a moment and talk about the intermediate value theorem. So this is different from the mean value theorem and Rolle's theorem. So here what we're going to do is we're going to say we have some function f. And for the intermediate value theorem, we don't actually need f to be differentiable. We only need f to be continuous. All right, so f is any continuous function. Then if f takes on 2 values, it has to be continuous on the interval. So you can't be like skipping values in the middle. And say it takes some value y1 here and y0 here. All right, and then we have some point in the middle. Let's call this z. So z is between y0 and y1. Then the intermediate value theorem tells us that there is some x in the middle, so that f of x equals z. So basically the function can't, if it's continuous, it can't skip any values in the middle. And so let's write that out formally. Say f is continuous on an interval ab. Then if z is between f of a and f of b, I'm going to just write this as is between because we don't actually know which one's bigger. So I don't want to write like f of a comma f of b because f of b might be smaller. I'm just going to write if z is between f of a and f of b. Then there is some x between a and d. So that f of x equals z. So let's do some examples. I've got some multiple choice practice here. So let f be a continuous function on the closed interval from -5 to 2. And I'm going to give you some values of f. Not all the values, but just some fixed values of x and f of x. So f of -5 is 0. F of -3 is 2. F of 0 is -2. And f of 2 is 4. So we're going to have two questions here. First, which interval must contain a solution to f of x equals 1? And then secondly, which must contain a solution to f of x equals -1? I'll just pause for a moment. All right, so for the first one, let's have, so over here, between -5 and -3, f of x goes from 0 to 2. So since 1 is between 0 and 2, the interval from -5 to -3 has to contain a solution to f of x equals 1. But that's not the only one, right? Because then it goes from 2 to -2, and 1 is between 2 and -2. So again, this interval from -3 to 0 has to contain a solution to f of x equals 1. And then 1 is also between -2 and 4. So that interval from 0 to 2 also has to contain a solution. Now, what about f of x equals -1? Now we're going to look at which one's -1 falls between. So -1 does not fall between 0 and 2. So f does not have to contain a solution between -5 and -3. However, -1 does fall between 2 and -2, and between -2 and 4. So both the intervals from -3 to 0 and from 0 to 2 have to contain a solution to f of x equals -1. All right, so let's now talk about the special case of the mean value theorem, which is Rolle's theorem. So basically, Rolle's theorem is just exactly what we get when we assume that f of a is equal to f of b in the mean value theorem. And then we're basically going to be able to say that our value, right, if f of a is equal to f of b, then we have a value where the derivative f prime of x is equal to f of b minus f of a over b minus a. We have a value where that's equal, but since these guys are equal, f of b minus f of a is 0, and so this is going to be 0. So let's do an example here. So we're going to have g of x equals sine x on the interval from 0 to pi. We want to find the value guaranteed by Rolle's theorem. The first thing to note is that Rolle's theorem does apply because sine of 0 is equal to 0 and sine of pi is also equal to 0. So since those values are the same, there is some value between 0 and pi where the derivative is 0. So I'll just pause for a moment so you can try that, and then I'll give the answer. All right, so Rolle's theorem tells us there's some value in this interval where g prime of x is equal to 0. So we know that g prime of x is equal to cosine x. So where is cosine equal to 0? We can just look at a unit circle pretty much. So cosine is this value. So it's equal to 0 at every single multiple of, well, it's equal to 0 at every pi over 2 plus some multiple of pi. But in this case, we just want our value between 0 and pi. So the answer is just going to be pi over 2. Let's do another one. Let f of x equal x cubed minus x. On the interval -1 to 1. All right, and we want to find the value c guaranteed by Rolle's theorem. All right, let's discuss it. So first, to know what Rolle's theorem applies, we need to check that the values of f on the endpoints are the same. So f of -1 equals -1 cubed minus -1, which is -1 plus 1, which is 0. And f of 1 is just going to be 1 cubed minus 1, which is 1 minus 1, which is also 0. So we can use Rolle's theorem. There is going to be some value between -1 and 1 where f prime of x is 0. So now we need to find f prime of x. So f of x is x cubed minus x, so we're just going to use the power rule again. So 3x squared minus 1, and this has to equal 0. So 3x squared equals 1. So x squared equals 1/3, and x equals plus or minus the square root of 1/3. Okay, so in this case, the square root of 1/3 is an absolute value less than 1. So in fact, both the positive and negative values work. They're both going to be between -1 and 1. So either one is a valid answer. And so there we go. Let's do a couple more examples. Let's say we have f of x equal to x squared plus 3. All right, find the value guaranteed by the mean value theorem. On the interval from 0 to 2. I'll just wait for a moment and then give the answer. All right, so first we need to know what we're looking for. So let's check. So our A is 0 and our B is 2. So we need to know what f of A and f of B are. So f of 0 is 3. And f of 2 is 7. So by the mean value theorem, there exists some x in the interval from 0 to 2, so that f prime of x is equal to 7 minus 3 over 2 minus 0, which is just going to be 2. So there's some value where the derivative is 2. Now let's find it. So we're just going to differentiate. F prime of x equals 2x. And we want this to equal 2, so x equals 1. And this is in our interval from 0 to 2, so that's good. And that's just going to be our answer. Let's do one more problem to practice the intermediate value theorem. So I'm going to let f of x be the same function above. All right, and then we know that f of a is 3 and f of 2, or f of 0 is 3 and f of 2 is 7. So the intermediate value theorem guarantees that there exists some x in this interval from 0 to 2, so that f of x equals 5. And I could have picked any number between 3 and 7, but I just picked 5. So the question is find x. And there might be more than one, that's fine if there is. I'll just pause for a moment to see if you can solve that, and then I'll give the answer. All right, so basically we're just going to set f of x equal to 5 and solve. So we have f of x equal to 5. So f of x is x squared. Oh, sorry. I meant to write x squared plus 3. Let me just fix that. So f of x equals 5. X squared plus 3 equals 5. Just subtract 3. X squared equals 2. And x is going to be plus or minus the square root of 2. Now x has to be between 0 and 2. So we need to take the positive square root, and that is between 0 and 2. So we actually are just going to have x equals the square root of 2. And that's going to be our final answer. So that's basically it for today. This was the last lecture where we learned new content. And next time we're just going to go through and review everything we've done so far. I'll just briefly go over all the topics we covered, and that'll be it.